In this lecture, we want to, as I mentioned on Monday, talk about the mainstream approaches to utility theory. And as I pointed out on Monday, the difficulty that's involved in this is the attempt by the mainstream to have, on the one hand, a mathematical treatment of utility, and then on the other hand, to have this connected somehow in a reasonable way, in a meaningful way to human action. This seems to be the difficulty, right? It wouldn't be difficult just to erect a mathematical treatment of utility. I mean, that would be simple. You could, make a bunch of assumptions and there you go. So that's not particularly problematic from a mathematical viewpoint. But the difficult part is to relate this somehow to real human action. Okay, how do we do that? That's the problematic part. And so that's what we want to talk about is the methods by which the mainstream has attempted to relate their treatments of utility back to the meaningful concepts that we have of preference and action and so on. So first, let's just briefly review what we mentioned on Monday about the Mengerian treatment of utility, just so this is fresh in our minds. And then we'll talk a little bit, just briefly, about methodological concerns, because this again stems from the mainstream treatment stems from the positivist, if you will, methodological approach, which conceives of the whole process of developing economic theory, or what an economic law is, and these kind of basic questions in an entirely different way from the causal realist approach. So once again, it's interesting to see this big picture. How are they developing these laws? What are the nature of these laws, like the law of demand, let's say, in contrast to the Mengerian approach. And this will help us to have context for seeing this other question that we're pursuing about the connection between mathematical treatments of utility and real human action. Okay, so on Monday we pointed out that in the causal realist view, valuation expresses itself in action and a preference. Right? So we just say in our minds that one course of action we prefer to another, or we prefer one set of means in pursuit of a particular end over the other possible combinations of means that we could use to pursue this end. So we're always simply choosing one option that we value more highly, and then setting aside an alternative option that we value less highly. We pointed out also that this notion of preference cannot be conceived of separate from action. Preference is the criterion by which we choose in action, and therefore our state of mind when we say, this is what I choose to do, as opposed to the alternative. The preference, in other words, is just that state of mind that we have by which we choose in action. It isn't disconnected from action. It's not a set of priorities that we write down that we then slavishly follow during the week or something like this. But what our state of mind is as we are engaged in the action we're analyzing. That's why preference is demonstrated in action. So every time we act, we reveal what our preference is, because by construction of the concept, we're always acting in a way that's consistent with our preferences. This is, again, just what we mean by preference, right? That we've chosen what we value more. How do we know we value it more? Well, because if we valued something else even more highly, we would have chosen that. Right? This is the logic of behind this idea of preference. Then when we broke preference down into its more basic components, which is valuing the different options, right? So preference is comparing the valuation of different options. We pointed out that this valuing, the value that we have in our minds of any particular option that's involved in acting, is subjective. And as we pointed out, by subjective, we simply mean that value exists only in our minds. Subjective doesn't have anything to do with the question of whether there's an absolute scale of values or ethical questions, or whether value is relative or just our opinion, or all these, those are all interesting questions, but that's not what in the causal realist view, we mean by subjectivity. By subjectivity, we just mean value exists in our minds. It has no extensive property. If it has no extensive property, remember the implication is it can't be measured. We can't come up with a common unit of value, saying that there's a util of satisfaction that we get from eating an apple or something. It's just a nonsense statement because we cannot have a common understanding of what a util of value would be to me. Right? Nor I could not have any sort of experience and therefore common understanding of what a util of value would be to you. To have any sort of meaningful unit of measure, it has to be public, right? We all have to be able to share the understanding, the objective understanding of what this unit is. A foot, an ounce, a Fahrenheit degree, or whatever. Okay, so we lack this with a utility or value. Therefore, we can't perform any arithmetic operations with value. We can't add them up. In other words, we can't conceive of the total utility of several units of a good as the sum of the marginal utility of the individual units, right? That's all just out the window. There isn't any way to reconcile this kind of summing up of utility with this view of preference. We can't obviously then subtract utility, one set of utility from another set of utility. We can't interpersonally compare utility. Again, most mainstream economists would agree with that proposition, right? They too don't think that we can interpersonally compare utility. Why do they think that? Well, they think that because they want to retain this basic meaning that that all of us bring as human beings to understanding value. Right? This just seems reasonable and obvious that this is true. But one wouldn't know this or derive this from any sort of positivist view. Okay, well then the last thing, just in summary of what we said before, is that, and this is a separate principle of value, value is not constant. That is to say, there isn't a constant quantitative relationship between external factors that influence how we choose an action and our action itself. Again, this is just a fundamental in the notion of choice. In other words, choice means that given the circumstances of the action that I'm engaged in, I could have done something else. Well, if I could have done something else, then obviously the external factors that affect how I choose do not determine my choice, right? I'm not sort of required to do something simply because there are a certain set of external conditions. Just because the price of a good goes down by 10% doesn't mean I must buy an additional 5% of the good or something, right? There isn't any kind of quantitatively constant relationships that exist in human action. This again is a separate feature of valuing things. This isn't an offshoot of subjectivity. This is bound up in all sorts of action, right? This is why you can't formulate, as we said on Monday, demand functions. Even when we have cardinal units of things like prices and quantities of goods, we can't conceive of the relationship between these in a functional sense because we have no constants. We have no quantitative constants by which we could, write an equation and then relate changes in price to changes in quantity demand. Okay, now as was pointed out again in other lectures, this view that we're presenting, it comes from this. It comes from praxiology, or this causal realist method. And remember, in this method, we start with axioms. So we say there are certain things that are self-evidently true, certain things that we reflectively know, and we can begin with the truth of these things. We have ends and means, and value, and so on and so forth. And then just through a regular process of deduction, we come up with these economic laws, right? And you've seen what the character of these laws happens to be, right? There are these universal causal principles that are involved in, we start with the basic ones that are involved in any and all action. So, we have ends when we act, we value, our values are subject to diminishing marginal utility, and so on and so forth. So we're deriving this first set of laws that are universally true of any and all action, and then we move on to the kind of subsets of laws that are true only in certain conditions, like the law of demand obviously wouldn't be true for Robinson Crusoe, since he doesn't exchange, and so this is a particular set of laws that applies only in particular social conditions where we have private property and money and so on and so forth. Okay, so we've got the general gist of this, and then remember when the rest of this, and you'll hear about this later in the week. How is this all then connected to empirical facts about human action? How do we connect this sort of abstract theorizing, these conceptual underlying structure of action to the empirical evidence that we see about action? And this is in the realm of history then. And so the rest of the schematic would look like this. We have what Mises like to call specific understanding. Here's where we get the specific concrete detail of particular instances of action that come from a combination of what we know or can learn about historical events and these laws. So the arrows of reasoning move like this, right? We reason abstractly from the axioms. We don't need to know anything about the particulars of the empirical case. We're just talking about the law of demand as it applies to all cases. And then when we want to apply it to know something about some particular case, like how about the housing market right now, what's going on in this case, it's a combination. We bring together the universal knowledge that we have with the specific things that we can learn about this peculiar case. Or to change my example slightly, and again, I don't want to go into this in detail. I'm just kind of giving you the framework here, which you'll hear about later. But to give you a particular case of this, we have the theory of the business cycle, and you've heard about this already, right? The theory of the business cycle just says if we have a fractional reserve banking system, right? We have a regular market economy, a fractional reserve banking system, especially with let's say a central bank, just for simplicity. If the central bank engages in monetary inflation through credit expansion, then this will, push down interest rates. It will lead to entrepreneurs to engage in a lengthening out of the structure of production, and this lengthening out of the structure of production is unsustainable because consumer because it's inconsistent with consumer time preferences, and eventually this inconsistency will manifest itself as the extension becomes ever less viable, right? It gets extended into increasingly riskier and less likely to be profitable ventures. Eventually investors pull back, right? And they say, oh, wait a minute, that's enough for me. This has gotten out of hand. And as soon as it starts to pull back, then the whole thing has the potential to crash, right? So the investors pull out of these investments, these malinvestments, and then the whole thing unwinds. Okay, so this is the general set of laws that apply to any and all business cycles, whether it's the Great Depression or the current one we're in or the one in the mid-1950s or what have you. But the current one we're in, well, we know certain things about it as an historical event, certain specific knowledge about it as an historical event that we can then add in. We can combine, right, with our theoretical knowledge for a complete historical analysis. So here we'd have to talk about Bernanke in particular, or what Greenspan was doing, how much the money supply increased, where the lines of credit expansion went, right, and what the particulars were, how high did housing prices go, how much was malinvestment occurred in Las Vegas versus other places in the housing market, and so on and so forth. These are all just, right, when we want to know everything that we can know about empirically about an historical event, this is how we do it. It's not a direct application of the laws to the event, right? It's a bringing together of two different bodies of knowledge, making them consistent. So that's how we do empirical work in the praxiological tradition. Now, if we take the view we take the mainstream view, the positivist view, then it looks like this. They also start with historical events, or they also have historical events, right? And they're right? The business cycle's been going on, and here we have this historical event. And then from this, they distill certain empirical facts. So they're moving this direction, logically. They say, well, we have had an historical event. Now, what's important about this event? What does Paul Krugman think is an important historical fact about this current cycle? He doesn't think, right, that Fed policy is an important fact to cite, the credit expansion and so on. No, he thinks something else is. Animal spirits, or he thinks that optimism, pessimism cycles, or aggregate demand, or something like this, right? So they select certain empirical facts from the historical event, and as Mises points out, these empirical facts are complex. That's one of the critical problems in applying the positivist view. These empirical facts are created in the complexity of the social situation that brought them about. They're not laboratory facts, right, that have been created in a simple, laboratory experiment where we can clearly see the causal connection by holding other factors the same. This presents some difficulty. And then these empirical facts, of course, are used to do statistical tests. And the statistical tests are of these laws of economics. Now notice, if you're going to do statistical tests of laws, then the laws have to be hypothetical. They have to be hypotheses. The law of demand, in other words, is no longer a conjecture about what would have taken place had prices been different in markets, and therefore help us to see the logic of market clearing, as we have it in the Mengerian tradition. No, the law of demand now is an empirically testable proposition. You have to be able to bring empirical evidence to bear upon the law to see whether or not, in the statistical sense, when price goes down by a certain amount, a quantity rises by a certain amount. Now, then the question is, well, by what process can you deduce or come up with these laws? Okay, well, that's kind of the model building part of their. So here on top, they have a model that they build, right, from assumptions. They make certain assumptions about the world, and then they have deductions, and then these laws pop out. So here, this is model building. Right? So you have the theory, and this is the theory part. Build a model. We don't, care so much about what the assumptions are in particular, just as long as we get testable laws. And then this is the empirical part. So we bring the empirical to bear upon the laws. You can see again that we won't go into this in all the details, but you can see that the character of these laws is entirely different. The Austrians are talking about an entirely different body of knowledge when they speak about economic laws, even though we use the same terms, like the law of demand or whatever the particular law might be. The conception of it is much different. Now, by the way, I might point out that and I won't talk any more about this, but one option that mainstream economists use in order to reconcile this kind of an approach to real human action, we mentioned that kind of the topic that we want to discuss here. Some of them say, look, when they apply this sort of approach to utility analysis and demand and so on, they say something like this. They say, well, let's just forget about coming up with anything like a set of laws that has meaning in this praxiological sense. Let's just develop an abstract model, completely abstract. Let's assume, in other words, that there aren't human beings. Let's assume that they're economic agents. And these agents are lightning fast calculators that are able to maximize their utility through massive linear programming calculations or whatever. They're not human beings at all. They're just ciphers of some sort, right? Mathematical ciphers. Then they say, well, okay, so if you're going to do it this way, and this again is not an uncommon approach taken by the mainstream. If you're going to do it this way, then how is it possible, even remotely possible, to connect this to real human beings? Well, it's connected to real human beings through this testing process. Let's just test it out, right? We'll make predictions based upon this model that we've come up with. Predictions about real action in the real world. And if our model predicts these things, well, then it's good and usable and helpful. And if it doesn't predict these things, well, then we'll adjust it. We'll abandon it or modify it and so on. And as you've seen lately, it's been revealed for everyone, of course, lately in this boom-bust cycle, the mainstream is not really all that, their track record here is not all that great, let's put it that way, in predicting. Maybe this approach, maybe they should reconsider this kind of approach. It seems like perhaps it's not a very fruitful way to proceed. Okay, well, what we want to do, though, is look at something else, right, which is if you're going to proceed in this mainstream way, start up with a set of assumptions and then deduce these testable laws, is there any way to make them, kind of reasonable? Is there any way to sort of build into this process something of the praxiological meaning that we know attaches to valuation and so on? Now, Murray Rothbard points out that there are two ways in which the mainstream attempts to do this. There are two different approaches that they take to trying, again, to have both a mathematical expression of the laws that could be tested quantitatively and this sort of causal realist meaning. And one he calls psychologizing. So he says sometimes they make assumptions that are assumptions about the psychology of human beings. So they make this underlying basic psychological assumptions. One example he gives of this is we mentioned on Monday is Samuelson's treatment of revealed preference. Remember where Samuelson says, let's suppose that people have a map of their preferences in their minds that stays constant over time, and then as they act under different conditions, it gets mapped out for us, and so we can see it. Rothbard says this is a psychological assumption, right? We're presuming to know something about the psychological state of mind of people. In this case, that their preferences stay the same over time. They're mappable over time. Another example of this would be to use questionnaires. So you see economists do this periodically, right? They'll use questionnaires, they'll send out scientific questionnaire and they get the results back, and then try to use the results to get a psychological profile, if you will, that they then begin with, and then they proceed down through this process of developing laws from that. Another example would be experimental economics. Right? Vernon Smith and he put a bunch of graduate students in a laboratory, and you play market with them. Give them play money or maybe even real money, and have them change the circumstances, see what they do, and so on and so forth. That would be another example of psychologizing. And he would say, well, hey, we did this experiment with them, and we see that, there's a law of demand. If we push the price or experimental price down sufficiently, they buy more or whatever, right? So this would be another case of this. Now the other option that's taken is perhaps even more common, is what Rothbard calls behaviorism. And by this he just means that they directly mathematize utility. They just say, let's assume that we can give a direct mathematical treatment to utility, and this would then give us a definitive, quantitatively testable a law. This would be something like a utility function or sets of indifference curves, which we'll look at in a minute. Another example of this would be, say, the quantity theory of money. So you're all familiar with this, right? So we have the quantity theory of money, right, is a stock of money times velocity is equal to the price level times the quantity of output. And then the assumption is made that V and Q are fixed. And now we have a quantitatively testable hypothesis. If M goes up by a certain percent, then P would have to rise by the same percent. And then we could test that out. So this is a behaviorist kind of assumption in Rothbard's topology. We just sort of directly make a mathematically trackable assumption. Okay, so now let's go to how this is done for utility theory. And as I mentioned on Monday, there are two approaches that you find in the literature. The first is what's called quantitative representations of ordinal ranks. So we don't want to give up our ordinality, right? Because the mainstream doesn't want to give this up entirely, because this does seem to be, in fact, the meaningful way in which we choose. We just say, I prefer one thing to another. So their approach here is, and again, both of these approaches, I should say, historically arose in the late 19th century. Both this and indifference curves, which we'll talk about next. So they're very well-worn techniques. They have a long history in economics, really going back to the kind of beginning of sort of the professionalization of economics. Okay, so anyway, it goes something like this. Let's suppose we have a preference rank, and to be neutral about this, let's say the options are A, B, C, right? So we have somebody who ranks option A above B, B above C. And so in the simplest sense, the quantitative representation would just be, we know since the A ranks above B and B ranks above C, that if we're permitted to quantify utility, that the amount of utility associated with A would be larger, right? So we can just assign a number to it. Let's just assign an arbitrary number to it. There's nothing, inherently useful about the number 95, but we'll call it 95. And then so on. And as long as we're doing this in a way that is consistent with what we know about the preference, right? We just say, okay, preference, a lower ranked preference must mean a lesser amount of utility. Then this would be a representation. This would be a quantitative representation of the ordinal rank. And since it's representing the ordinal rank, we can then work with it. We can sort of just now directly, we can mathematize this, right? We can set up a mathematical function here, and then we can just treat this, we can just use this mathematical function in lieu of, as a representation of, if you will, the ordinal rank. Now, again, let me just kind of run through the historical arguments back and forth about this. The immediate argument that was made against this, and you may see right away what retort would be made, is that while the numbers are arbitrary, the quantitative structure is not, right? You've imposed a particular quantitative structure on these numbers. So, you don't need 95, right? You could start with the number 10 or whatever. But as long as you leave the, let's say the gap size the same between these numbers, you've imposed a quantitative structure on this ordinal rank that obviously doesn't exist in the ordinality. Okay, so that seems somewhat problematic. The numbers, again, are okay. You choose any arbitrary numbers that you want. But it would seem that you can't represent an ordinal rank by choosing a particular quantitative structure. Now, this was put in a particularly inapt way in the debates. What was argued in the debates was that while you can make these numbers arbitrary, you can't make the gap sizes arbitrary. Once you say I'm going to make this 10, and I'm going to make that 10, and the next one 10, and so on. You've imposed a particular quantitative structure here that's not representing, so to speak, the ordinal rank. So the reply to this was, well, we can still proceed in exactly the same way just by doing linear transformations. If all you're worried is about the gap size, we could just double all these numbers, right? We could double all the numbers, double the gap size, and we would have essentially the same function here. Problem solved, right? Then we could cut the numbers in half. We could just do linear transformations of our original function. And so QED, this is fine. This is a perfectly reasonable way to proceed. If all you're concerned about is the gap size. Now, it was actually Mises who pointed out, and again, I'm not sort of relating this in exact historical chronology or anything, but it was Mises who pointed out that, no, wait a minute. Don't we all agree, this is post-marginalist revolution, don't we all agree that there's a law of diminishing marginal utility? And if there's a law of diminishing marginal utility, how can there be even drops here? Wouldn't you have to have increasingly large drops, so to speak? Wouldn't you have to have some non-linearity, to put it differently? Well, sure, of course, right? So So this was for a while abandoned, and then say in the by the early 1900s until after World War I, this kind of approach was abandoned, precisely because of this critique. And then it was reborn by De Brugge in the 1940s, and his approach was a little bit more sophisticated, but really no more satisfactory. What he said was this. He said, and again, I'm kind of summarizing this quickly, but he said, okay, let's suppose again we have these ordinal ranks, and then we have what we'll call ordinal numbers. We can assign ordinal numbers to these ranked positions. And typically, when we think of ordinal numbers, we think of things like first, second, third, right? That would be kind of the basic notion of an ordinal number. This is the first place, the second place, the third place. Okay. So he says, let's just treat these place positions as numbers. In other words, just say this is 1, 2, 3. Right? That's an ordinal number. So this becomes just a set of cardinal numbers. 1, 2, 3. And then what he shows is that from this set of numbers, you can then get another set of numbers, like we had originally, this functional set of numbers, like this. Right? That's the representation theorem. The representation theorems only show that you can get a cardinal set of numbers from ordinal numbers. They don't show that there's any sense that you can make of this notion of ordinal numbers relating to the ordinal rank. That's the problem. Right? The problem is this step. The problem is not this step. This step is easy to show. Right? You don't need any advanced mathematics to show this. Right? The problem is, does it make sense? Is it really a representation of the ordinal rank to say we have 1, 2, 3, as opposed to saying we have first, second, third? Well, no, they haven't shown that. I mean, that's what needs to be shown. And let me try to give you an analogy to illustrate the problem involved here. This seems a little bit abstract, I know. Let's suppose that we had this situation. Let's suppose that we knew from whatever kind of analysis we had this market. And we knew, I don't know how we know this, but let's just presume that we know that we have a demand for X that looks like this. It's a linear downward sloping to the right demand, sort of a normal looking demand curve. Let's suppose that we knew that this was the true demand curve. Just like we know that we have what truly exists is this ordinal rank. So this is the real thing. Let's just assume this. Now, okay, who knows what happens as you move along, from your basic economic courses. As you move down this demand curve, the price and quantity combinations that you get at different points, let's say P1 and Q1 and P2, Q2, and so on. What happens to the total revenue, the price times quantity, as you move down this demand curve? A linear downward sloping to the right demand curve. Yeah, it increases and decreases, right? It increases to a maximum at the midpoint, where the elasticity is 1, and then it'll decrease as you go down further. So the total revenue curve, it's hump-shaped. It would increase at first up to roughly point B and then decrease. That's implied, right? That's a logical implication of this downward sloping to the right demand curve. Okay. So let's say we then had a guy who came and he said, now wait a minute, for another reason, I want to draw this demand curve differently because I want to derive a somewhat different result that I can't get from a linear demand curve. And so he draws the demand curve. He says, let's represent this linear demand curve by a rectangular hyperbola, like that. Let's call that a representation. And he has some fancy mathematical way of showing that this is a legitimate representation. We're not concerned with that question. We just want to see the analogy, right? Okay, and he wants to do this because he wants a curvilinear demand curve because he has some interest in, taking the first derivative and not having it vanish or something. Whatever. He wants to do something with this, right? By the way, that's not an arbitrary claim. That's exactly what is being done by the mainstream when they say we want quantitative representations. They want to do something with the quantitative representation that they can't do with the ordinal rank. They want to have a mathematical treatment of these concepts, right? They want a mathematical demand curve that they can test empirically. It will give them results and so on. So let's say we do this. Now, what's the problem with this? What do we lose if we do this? What happens to the total revenue as we move from point to point on this curve? If the elasticity of this curve is uniform everywhere, it's constant, right? It's constant. We've made a big mistake then, right? Have we really represented this demand curve with this one? No, I would say no. I would say that's just, we made a fundamental error in our thinking here. Even if we could show mathematically somehow that this is a representation, however we might do this through some sort of mathematical process. Now, let me point out one last criticism of this approach. Even if it were possible to show, even if we accepted this demonstration that there's a quantitative representation of an ordinal rank, this still would not be realistic. This still wouldn't pass the test of being connected to the kind of basic causal realist notion of preference. Because remember, we said that there are really two conditions involved in what we know about valuing things from a Mengerian perspective. The first is this subjectivity, right? We have no cardinal numbers and we're not able to do this sort of mathematical treatment. And the second is constancy. Well, we may have, through quantitative representations, we may have dealt with the subjectiveness of the preference rank, the ordinality of it, but we have not addressed this question of constancy. In fact, we've assumed that there's constancy involved. Otherwise, well, our mathematical representation is of no good to us in empirical testing if it isn't constant. Right? This is the Samuelson claim about revealed preference, right? We have to have constancy in order for the empirical action that we take to map out the demand curve over time. And so we've only, in this approach, satisfied one of the two conditions that would have to be taken account of. Okay, now let's do indifference curves. This is probably more familiar to those of you who've had some economics. You've been exposed to indifference curves, but maybe not these representation theorems. Okay, with indifference curves, again, a certain set of assumptions are stated at first. Remember, that's how the modeling process goes. We make certain assumptions and then we deduce things from them. And the assumptions are these. Let's suppose we have, just for simplicity, we could do this with many goods, but let's suppose we just have two goods, X and Y. And we make the following set of assumptions about what a person can do in establishing valuations of X and Y. X and Y will be valued together, amounts, I should say, of X and Y will be valued together in bundles. So let's suppose we have bundle A, and bundle A would be, let's say, 2 units of X and 3 units of Y. And then bundle B, with a different combination of X and Y, might be 3 units of X and 2 of Y. Something like this, right? And the assumption is that a person can always say one of 3 things about any 2 bundles of X and Y. That A is preferred to B, or B is preferred to A, or A and B are, the person is indifferent to A and B. Gets the same utility, if you will, from A and B. All right, so that's the first assumption. Right? We could, for every combination of X and Y, a person can say this. Then these preference orderings are transitive. So if A is preferred to B, B is preferred to C, then A is preferred to C. So all preference orderings are transitive. More of good is always preferred to less. That's also an assumption. And then the final one is this idea of what the mainstream calls the marginal rate of substitution of X for Y. And this is the statement of it, that a person will trade successively smaller amounts of Y for each additional unit of X while leaving utility constant. Okay, so as a person trades off X for Y in the bundles, A, let's say, having 1 more unit of X compared to B, then the person would be indifferent. That is, he'd have the same utility as he trades off X for Y only when he's trading for each additional x, he's trading smaller and smaller amounts of y. Well, it's just called the marginal rate of substitution. Okay, and then from these assumptions, if we accept them, and we'll talk more about what this means critically in a minute, but from these assumptions, then you can derive the whole indifference curve framework, if you will. That indifference curves do exist, right? Because all combinations between which the person is indifferent can be stated by the person. You can say, yes, I'm indifferent between A and B, and between B and C, or whatever the other combinations are. They will not intersect because of transitivity. If you map this out on a diagram, you wouldn't get any inconsistency between the things that you're indifferent between and things that you prefer, right? So you could if you didn't have certain assumptions. When you draw them again graphically, they would have negative slopes. The indifference curves, the set of combinations between which you are indifferent for a given utility level. Farther from the origin, as you draw them, they would have larger amounts of utility than closer to the origin. And because of the principle of marginal rate of substitution, they would be convex to the origin, right? So most of you are familiar with this, and if you're not, I don't have time to deal with all the technical aspects of this, but I think you can follow the basic gist of this. Okay, and then from this sort of an arrangement about preference, right? This is all connected to preference. Right? The only thing we've added, well, we have a sort of a strange way of bundling things to prefer them, right? That's sort of odd, but we just have preference and this additional notion of indifference. So this is the way in which it's supposed to be connected to our basic understanding of preferring one thing to another. And so now this person who has this indifference map in his head can maximize his utility. He can get the most preferred bundle given his budget constraint, given his income and how much the vendors are charging for the different goods. So let's have this numeric example. Let's say that mathematically utility is just x times y. And so we would have one utility curve or indifference curve that gives this person 1,250 utils of utility. And the x and y combinations would be these: 10 and 125, 25 and 50, 50 and 25, and 125 and 10. Okay, so if I multiply each of these, I get 1,250, right? And so the person would be indifferent between all these different combinations. He doesn't care. He gets the same utility for x10, y125 as he does x50, y25. And then let's put up another one that has twice as much utility, and a few combinations here. Let's say we'd have 20 now and 125, and say 25 and 100 would give us the 2500, 50 and 50, and 100 and 25. So that's how we map. We could do that. Mathematically, we could have an indefinite number of these indifference curves. Each one of these is an indifference curve because the utility that the person gets is the same for every combination listed. Okay, now let's suppose the person has $100 of income, and the price of X is 2, and the price of Y is 1. And the question is, what will the person do? How will he spend this income to get the greatest utility? We can see a quick check. With this price structure and given this income, he can't buy any combination on U2, right? He doesn't have enough money. And when we go over here to U1, well, he can't buy this combination, right? That would cost way more than $100. But he is able to buy that combination, right? So he spends $50 to buy 25 units of X, and he spends $50 to buy 50 units of Y. So that's the one he would choose, right? This maximizes his utility. That's the most utility he could get given this arrangement. Now, if we want to map out a demand curve, all we have to do is I'll change the price of X. We can change the price of either good. But now we can see what would happen if the price of X falls. Okay, so if the price of X falls to $1, now he's able to move to U2. Right? He can find this combination on U2 and buy it. So he's better off. That's what he would do. He maximizes his utility now by moving to the higher indifference curve. Okay, so this This is the derivation then of the law of demand. This is the companion mainstream logistical demonstration to what we did on Monday, right? Just with the preference rank. And most of you have seen this graphically. I won't bother to put it up just in the interest of time, but right, you can do this graphically, you can do it mathematically, set up the Lagrangian, and you can solve all this just with fairly straightforward mathematical techniques. Okay, so what's the problem with it, or the set of problems with this? Well, first of all, let's just go back to the very basic starting point and make a comparison between what's being done here and what's being done in the Mengerian tradition. From the causal realist view, remember the preference rank would look something like this. All right, so here we have this guy, and he is not willing to buy the first unit of X for $2, but he would buy it for $1. And then because of diminishing marginal utility, because he's putting the second unit of X to some less valued end, he values it less highly than the first unit, so he's not willing to buy it at this price. But he would be perhaps at some lower price. And so, as we said before, that's how we derive the law of demand. Notice this is an integrated, or Rothbard calls this a uniform or unity preference rank. Every aspect of the choice process is on the preference rank. Is being valued, in other words. How could it be otherwise? Okay, now let's do the same thing let's construct a preference rank for this indifference example. Okay, it would look like this. Let's say, remember these are ranked in combinations. So let's say 50x, 50y. That would be ranked very highly, right? That's a U2 utility level. And this also would have exactly the same rank order as 25x, 100y, or any other combination on U2. Then below this would be ranked this combination, say 25x and 50y. And then there would be other things ranked at the same level, 50, 25, right, from U1, these two combinations. And then hypothetically, there would be other things ranked below this, let's say 10x and 50y. Right, since more is preferred to less, that would be ranked lower. 0x, 50y, and so on. Okay, so what's obviously missing from this? What's not being valued here? Well, okay, you're absolutely right. I was thinking of something a little bit, well, it was just sort of visually more obvious than that, but you're right. You're absolutely right. There's no marginal utility. What notion of marginal utility do we have here? Okay, that's problematic, right? In other words, what's replacing it is this idea of the marginal rate of substitution. And again, we'll talk about that as a separate item in just a minute. But what I wanted to say was, money's not here. There's no money on this preference rank. Money is never valued in the mainstream view. Now, how can that be, right? What sort of a grand omission is this? How can you actually have a realistic, or attach this to a reasonable treatment of human action when there is no valuing of money? Money in this view is simply it simply has objective value. It has some sort of given objective value, right? In fact, one way to perceive of the choice that's being made within the indifference curve framework is, again, you see this graphically if you draw an indifference curve, is that, different budget constraints would hit the indifference curve at different points, right? And what you do to get the maximum utility is you drive that budget constraint further down toward the origin so that it's just tangent to the indifference curve. So the choice is not between the utility of different options on the indifference curve. You're indifferent between those. That you make the choice of those different points on the indifference curve by how much money you spend to buy them. But money isn't even being valued. So what sense does this make, right? This makes no sense whatsoever. Now, I should say, just as a matter of logical consistency, that this does make sense to the mainstream approach because, of course, in their theory of general equilibrium, it doesn't contain money. They don't think you can apply subjective value reasoning to money. And so it makes sense for them to exclude it in this approach. But we should notice this at least as a criticism. This, from our viewpoint, from the causal realist viewpoint, this is a deficiency, certainly, of their approach. Okay, now another problem with this, and you've seen some of this in the literature if you've been reading some that's been written about this idea of indifference. So there's been, back and forth between Brian Kaplan and some of the speakers that are here at the Summer University. Okay, so here's the analysis of indifference. Indifference could mean one of two things. From a causal realist view, it could mean one of two things. Indifference could mean, like Brian Kaplan says, indifference could just be a psychological state of mind. And if it is, then perhaps we can choose even when we're indifferent. That's basically one of the claims that he makes. Hey, you guys are getting all upset about nothing here. Indifference is just a psychological state of mind in which we can still choose. He gives the example, right? I get up and I get dressed in the morning and I'm sort of indifferent between the green shirt and the red or whatever, and so I just choose, one's on top of the other, so I just take the one on top. Okay, fine. We could mean that by indifference. If that's what we mean by indifference from the causal realist view, why should we pay any attention to this principle at all? What could this principle possibly add to the causal realist analysis? The causal realist analysis, remember, is just about choice. It's just about choice itself. It's not about how much we gain when we choose. It's not about the mental process we go through when we choose, or it's not about the psychology of choosing. It's just about the fact of choice. To give you again a counterexample or sort of a analogous situation that seems more absurd. What if then, why couldn't we respond to this view by saying, well, what happens then when we're passionate in our choice? Does that change the causal, does this sort of upset the logical structure of the derivation of demand curves? If we say, when we're passionate, that somehow introduces a anomaly into our logical apparatus. No, it doesn't. It doesn't matter whether we're passionate or indifferent when we choose. Now, the other thing, of course, indifference could mean something else, right? Indifference could mean what it seems to obviously mean in the mainstream treatment, which is we cannot choose. When we're indifferent, we cannot choose. We have no basis of choosing between these options. We're indifferent between them. We can't choose between them. How do we choose between them? We choose between them, as I said before, on the basis of how much we have to spend to buy them. We don't choose between them on the basis of utility. We can't. We're indifferent. That's what the mainstream has always meant by indifference. We can't choose. Well, okay, so if we're in a state of indifference and we can't choose, and we're not acting, and what can we possibly say about states of non-action? Right? Economics is about action, not about states of non-action. So again, here it doesn't seem like a very viable option to take in trying to find some defect in the causal realist treatment of things. The causal realist view is never claimed to be a theory of both action and non-action. It's claimed to be a theory only of action. And, well, action requires choice, and choice requires preference. And if we're indifferent, we're not choosing and we're not acting. And therefore, when we're in states of indifference, we're just outside of economic theory doesn't apply. Okay, fine. That's not particularly problematic. Okay, then this idea of the marginal rate of substitution, the diminishing marginal rate of substitution, the convexity of the indifference curve. Here we see that, and someone had mentioned this, about the idea of diminishing marginal utility. We see a critical difference between what, in the causal realist view, we mean by diminishing marginal utility and what's meant in the mainstream view. Remember, in the causal realist view, diminishing marginal utility is a logical principle. It says, because my means are scarce, I can't satisfy all my ends with with the means available to me. I choose a unit that's appropriate to the end to which I wish to attain, and then I apply that amount of the means to my highest valued end. Having satisfied my highest valued end, any amount of a means that I have left over, any additional unit would have to be logically applied to a less valued end, and therefore I would impute less value to it. Right, so we're talking about different ends that are being attained as we move down the preference rank. We're choosing the amount of the means precisely because it completely satisfies the particular end to which we're putting it. And then having satisfied that end, we move on to another end. This is the notion. Well, that notion doesn't appear anywhere in the mainstream view, right? What the mainstream replaces this with, so to speak, is this idea of the convexity of the indifference curve. The marginal rate of substitution is diminishing as we move down the indifference curve. And we get this result, as I said before, by holding utility constant and adding units of x and seeing how much y we would have to give up to keep utility constant as we proceed to add more and more units of x. Well, why should we think that additional, smaller and smaller amounts of y are being given up for each additional unit of x added to keep utility the same? If we go back a step in logic, what exactly are we saying is necessary principle of preferring things and so on from which we can derive this principle? Well, it certainly isn't the notion that the Austrians have of diminishing marginal utility. Maybe you can derive this principle from something like saturation, again, a psychological principle, right, where we're adding additional units of x. Let's say we're eating additional ice cream cones. We're sitting down at lunch and we have one ice cream cone and then another one and then another one and another one and another one. And we're willing to pay less and less money to get each additional one because to keep our utility the same as we're trading off these goods, we're not getting the same utility out of each additional ice cream cone. Why? Well, we're getting full of ice cream. It doesn't taste as good to eat the sixth ice cream cone, right? So this could be but this is just a psychological principle again. Principle of saturation, we might call it. This is not the idea of diminishing marginal utility. It's a foreign idea, or again, a psychologizing, as Rothbard would say, idea. Now, let me also point out that this whole apparatus of indifference curves, remember, was designed to do one thing. Why go through this whole elaborate process unless you wish to have your mathematical treatment of utility on the one hand and have your ordinal preference meaning on the other? If you don't care about this connection between the two realms, you would just go straight to the mathematical approach, right? Which, again, as I mentioned, many mainstream economists do. They say we have economic agents, not real people, and this is their utility function, and off we go. So if we're trying to make this balance between the two or see this connection between the two, well, we have this difficulty, right? And the difficulty is we've expressed this point of optimization. Again, graphically you could see this. I didn't bother to do the apparatus, but where the budget constraint, the slope of the budget constraint is equal to the slope of the indifference curve, right, where they're tangent. We have this equality at that point. This is the utility maximizing point. Okay, and as long as we say, well, the marginal rate of substitution is just the marginal rate of substitution, we can maintain, the mainstream economists can maintain this preference ordinality on the one hand and a mathematical treatment of utility on the other, or at least the appearance of this. But typically, of course, the books go further than this, right? They say, the marginal rate of substitution of x or y is just the ratio of the marginal utilities. You can deduce this again if you have utility functions. Okay, well, wait a minute. I thought utility was ordinal. This is not, we can't conceive of this as being ordinal, right? This marginal utility must be cardinal. This must be a number. We can't again have something like first rank and then fourth rank. That's not a ratio. That doesn't make any sense. Or sometimes you even see it this way, right? That the marginal utility gain per dollar spent on X is equal to the marginal utility of gained per dollar spent on Y, right? The optimization point. The person is allocating his money so that he doesn't have any marginal differential between the utility that could be gained from shifting money between X and Y. But again, if we're saying something like this, we're just baldly claiming that there's a cardinal utility. And so the cat is out of the bag, so to speak. Now, let me just briefly mention two other problems with the indifference curve, so kind of hidden or tacit assumptions of this indifference curve analysis. Again, if you've seen this in the textbooks, you notice that there are always these utility functions are offered and the indifference curves are drawn with the assumption of continuity. The functions are continuous. Well, where does that come from? How do you deduce continuity, mathematical continuity, from preference ranks? Where in the process of any of this development did we ever deduce the notion of continuity? Why shouldn't we have discrete breaks like like I've done it with these utility functions. And if we just have dots instead of smooth, continuous curves, how can we find tangency points? How can any of the rest of the implications from this work themselves out? Now, again, this may not be too problematic. Maybe there's, you could do this with discontinuous functions, perhaps, if you had big enough computers or whatever. But this does seem to be somewhat problematic, at least in the standard kind of treatment of this, where this is glossed over. No one ever bothers to address this difficulty. And then we might also mention that even if we go all the way with the mainstream on all of this, and we say this is fine, we'll accept this, and it's a perfectly good way to have our cake and eat it too, it still requires, in order to have empirical demand curves derivable from this system, it still requires constancy. Now you're saying something like, people have constant, or your economic agents have these constant, unchanging utility functions in their minds, and then they simply respond automatically or deterministically to changes in external conditions. And as long as their utility functions stay the same, what we see, the prices and quantities bought that we see in the market, would be empirical evidence, facts that we could use to test the quantitative structure of their utility functions. We know they have utility functions, but we're uncertain about the quantitative definiteness of them. We don't know what the parameters are, and we're testing those. So again, we haven't really dealt with this second aspect of valuation that's given full head in the Mengerian tradition. Okay, I've exhausted the time, so thank you all.